Welcome to Coercion and Deterrence. I'm the professor, Phil Haun, and today I have a primer on causality for international relations. It's meant to help those coming to this course in the MIT Security Studies program, and it's meant to be a short refresher for most, but also provide some insights for those who are not familiar with the terminology. So, you'll hear in these courses discussions about DV, IV, intervening variables. What do we mean? Well, one recommendation is Stephen Van Evera from the program in the late 1990s published a short primer on qualitative methods that's quite useful. So you may want to take a look at that. It doesn't take that long, good for your bookshelves. It's concise, it focuses on qualitative methods, and it's kind of the language that's used. Some of the language is not used as much anymore, but it'll give you a good idea of the primary frameworks that we're talking about here, which is dependent and independent variable analysis, which is critical to the scientific method, which is what political scientists have imported from what we call some of the harder sciences. And the importance of it is it provides a framework for approaching phenomena, studies of war, studies of deterrence, political violence. It gives us questions to ask of what is it we're studying? What are the causes of it? How do what we're studying, how does it vary over time? And what causes the variation over time? These are some of the critical questions that we're going to be asking as we approach whatever subjects that we have. And this course is International Relations and Security Studies, so that's what the focus will be on. So what are variables? Well, that's a good question. It's a little bit different in different fields like economics, when we might talk about interest rates or dollars change. Here, when we're talking about the study of violence, we could be talking about weapon types. We can think about relatively low-level weapons like a knife, all the way up to a thermonuclear bomb. You can see that there's variation over the types of weapons, weapons delivery systems, you name it, there's variation. Or we could be talking about the international system. We're talking about states, and there could be variation in the types of states. Authoritarian, even within authoritarian systems, there's variation in terms of types. Likewise for democracies and degradations in between. We might be talking about outcomes, let's say war outcomes. If it's a brute force war, victory, defeat, or stalemate, or escalation are some of the possible outcomes. If we're talking about achievement of foreign policy objectives, the degree of success. If we're talking about limited wars that end in some type of compromise, the degree to which the compromise favors one party over the other. Or maybe in terms of war outcomes, you might be talking about the length of the war, the size of the war, the destructive nature of the war. Or in limited wars, you could also think in terms of the risk of escalation to higher levels of violence or nuclear exchanges, where that may not actually occur. You may not see the variation because the risk itself is sometimes obscured. But here we're talking, those are the kind of variables that we're going to look at. There's other types of variables as well. Geography, technology, organizational type, maybe at a lower level, it's tactical type of variables like light or dark, weather, you name it. There's all kinds of potential independent variables or intervening variables. These are oftentimes, there's keywords to key you in that we're talking about independent variables. You can hear about factors, exogenous variables, that's a scientific term, which means the change comes from outside the system. And if that's the case, then dependent variables means whatever we're studying, whether we consider it a system or a process, variation comes from within that system or the variables within that system. So they're sometimes called endogenous variables. Just to show that we're not making this up, you can think about your work with mathematics, algebra even, and functions just simply show the relationship between variables, the dependency. So if you got some function y equals a function of x, you're already identifying the exogenous variable, the independent variable being x, and the endogenous being y. And you can see from the example here that I've graphed, y equals 1/2 x. You can see the variation of y is positively related to 1/2 the rate of growth of x. That's what we're talking about here. What causes what and to what degree? Causality, you can think Stephen Everett does a good job of flowing out all kinds of causal relationships. Sometimes you'll hear this like in people talk about ways, ends, and means. Ways and means are some type of independent variables that determine ends. Here I have an example from the natural sciences. The IV is the sun rises, which causes the rooster to crow. We would think that that is more likely to be the causal rather than rooster crowing causing the sun to rise. Second is an example of IV with an intervening variable and a dependent variable. We have a sunshine producing photosynthesis, which causes the grass to grow. Now, notice I've given a single IV here, but there's multiple IVs in this. There's also cloudiness, which affects the amount of sunshine. You can also think about where in the seasons and latitude of where the grass is determining the amount of photosynthesis. You can talk about the type of grass, the seed itself, and the degree to which it reacts to photosynthesis, quality of soil, you name it. There are potential IVs, and one of the key aspects of a political scientist is determining which ones of these are significant and which ones can we ignore. One of the key aspects of when we're examining causality is being careful not to equate correlation with causality. And the quantitative methods are very explicit in the fact that their measures are on correlation, and you can't draw causality from that. And so does the IV actually cause a change in DV, or are they simply covariant? I mean, they're moving together in some predictable way. Here's an example I just drew from the internet of an example of correlation that's not necessarily causation, is ice cream sales and shark attacks over a period of time. You can see there's a strong correlation between the two, but we wouldn't necessarily want to draw causation either way. That increase in shark attacks cause an increase in ice cream sales, or increased ice cream sales increases the likelihood of shark attacks. Although I'm sure you're very creative to try to come up with some possible logical explanation, like an increasing ice cream sales slows down swimmers who then are more subject to shark attacks, but that's not necessarily likely. So this brings up the idea of omitted variables. This is, hey, what are we missing? We're looking at a system, but we might be missing key variables that we haven't considered. In the previous example of ice cream sales and shark attacks, we might be missing seasonal temperatures as potential IV. And the first example here is increase in temperature leads to an increase in ice cream sales. Okay. Likewise, the second example, an increase in temperature may increase the number of people who go to the beach and the number of people who swim in the water, and this increases the potential for shark attacks. We could go on like this forever. We could take a different approach, which is an increase in temperatures increases the amount of algae, which increases the amount of small animals that become subject to smaller fish that are ultimately leading to sharks being drawn closer to the shore in the summer near the beaches where people are populated, and this increases sharks. The idea is that there's IVs, there's independent variables and dependent variables, and where we draw the line is really dependent on what we're studying. So if we're interested in studying ice cream, or let's say shark attacks, then we should be interested in the variables to the left of that, the intervening variables on the number of people swimming in the ocean. We also should be interested in potential IVs, such as the temperature. We might be interested in how much beach there is. We might be interested in other variables that are considered independent to shark attacks. Omitted variable is a key aspect here. You also hear this idea of endogeneity problems, right? Which is in a singular world or a linear world, X causes Y. But in the world we live in, there's interaction. And so how do we determine what causes what? And so I drew from Charles Tilly's famous saying, war made the state and the state made war, to say what kind of causality here is here. Does it that war causes the states to begin to extract resources in order to organize to fight those wars? Or is it that the states themselves, when organized, end up provide them the capability to fight wars and the incentives? Okay, so, and in part, this is the causality here. It first off is a recognition that endogeneity is a concern, and then questions on how do I isolate it? Never perfect, but enough to do the study. And so for week one, we're looking at Bernard Brodie. I'll just throw it out here that he early on talks about missiles and how that effect is on strategy. And so you could think about weapons themselves have an effect on strategy. But later he talks about in peacetime, the strategy you adopt can actually affect what weapons you acquire. So if you adopt a secured second strike capability, then you're more likely to invest in weapons that are more secure and can survive a first strike and retaliate. That's the idea. We have to understand that endogeneity is there. There could be some endogeneity in the independent variables as well. And then this isn't actually on causality, but it's a good time to discuss the probabilistic nature of the study of security studies versus deterministic. And so I got a simple example. If you put money in the bank, that bank is backed up by the US Treasury, which is defined by finances having zero risk. Then the $10 times the interest rate over a period of time gives you a deterministic amount of money in your account. Simple example, obviously a graduate student would begin to question this, but let's go ahead and take that as the example of a deterministic outcome. Probabilistic, though, recognizes that the world randomness occurs. We can't capture every variable, and that if you, the way I talk about it is if you fought a war, if you could fight a war 100 times simultaneously in different metaverses or whatever, how many times would it come out one way? How many times would it come out another? Or another way to think about it is, why is it that games like American football games are played when the odds are already taken and the experts already determined, have predicted who's going to win the game before the game is actually played? Well, as we know from watching sports, the outcomes are probabilistic. One of the reasons that the World Series or the NBA playoffs are 7 games is recognizing that on any given night, the best team doesn't necessarily win. So the example I have is I just went and looked at the lottery. The lottery is a perfect example of probabilistic outcomes. You spend X number of dollars to buy a ticket. There's a certain positive probability that you'll win. Well, it's dependent on the size of the lottery, relatively low. And then the question is, in this case, what's the value of that lottery ticket before the announced winner? So here I looked at online and I found a $2 ticket. For this particular Powerball, it was 439 million. And the chances of winning were over 292 million to 1 in 292 million. You multiply the pot by your odds, and you see that once you purchase that, you spent $2, the expected value of that ticket is $1.50, based on probabilistic. Now we know the actual outcome is either going to be 0, although those of you in the lotteries understand that there are intermediate payoffs. But for this example, let's just say it's all or nothing. The value is 0 or the value is 439 million. This brings to the last topic I want to discuss, which is expected outcomes. So normally we don't talk about actual outcomes because that's life that's already occurred. We're interested in decisions that to produce future outcomes, and those are all expected. And they tend to be probabilistic in nature. And so when you give a value like why would somebody pay $2 for a $1.50 expected value lottery ticket? Then you have to bring in this idea of uncertainty and risk. And so from the previous example, you see why would somebody really buy a lottery ticket if the expected value of it is only $1.50? Well, there's different risk tolerances, right? So some people like to play the lottery just for having the hope. Others, that would be more risk seeking. Others would never play the lottery because they don't, either for moral reasons in terms of gambling or because they value the money they have much more than what they would expect to get. Even risk neutral, sometimes risk neutral people might consider the lottery. And I give an example from political science of what's called gambling for resurrection. That $2 in your pocket actually means nothing, and having a lot of money actually could particularly save you. Then you might be willing to buy that lottery ticket. Here, gambling for resurrection is a political leader willing to take those extra risks because they think they're going to lose an election or be thrown out of power, and there's a positive probability that whatever risk they take might turn out well and they can stay in power. Okay, so that's the topics that I wanted to talk about today. Causality, we're going to be talking about independent variables, dependent variables, intervening variables, the causal relationship, thinking about omitted variables, thinking about endogeneity concerns. And so these frameworks and this language will help us to approach the materials that we are looking at. They give us the key questions to ask on the front end. And so I hope this a primer is useful. There's all kinds of methods books and methods courses I know some of you have taken. The one I've referred to is Stephen Van Evera's book on Guide to Methods for Students of Political Science. Thanks.